In today's lesson, I'm going to show you how to use trigonometric ratios to solve for unknown angles. So the trigonometric ratios are outlined on the top of your screen, and remember we use SOHCAHTOA as an abbreviation for these ratios. So example 2 tells us to find the angle theta correct to the nearest degree. So before we begin solving for unknown angles, what we have to do is we always have to identify the two sides that we've been given. So if I drew an arrow from the angle theta, it hits the 20 centimeter side, so that 20 centimeter side represents the opposite side. This 13 centimeter side is right next to the angle, so it's the adjacent side. The hypotenuse has no information, so it's not useful for us. So using these two sides, we need to pick the most appropriate trig ratio to use. So writing out SOHCAHTOA again, I need to pick a ratio that contains both the opposite and the adjacent side. So looking at these three, you can see that TOA is the only one that has the opposite and the adjacent in its ratio. So TOA stands for tan theta equals to opposite on adjacent. So once you've picked the most appropriate trig ratio, you go in and you substitute the values that they've given you. So tan theta, so theta remains as is because that's what we're solving for. Opposite is going to be replaced by 20 centimeters, and adjacent is going to be replaced by 13 centimeters. So now the aim is to solve for theta. So we want to isolate theta, we want to make theta the subject. So to do that, we need to do the opposite operation of tan. So the opposite operation of tan is tan inverse. So I'm going to multiply tan inverse to both sides. So I'll just put 20 on 13 in brackets because that's what's going to come up as on your calculator. And tan times tan inverse cancels out. So what we have is theta by itself and tan inverse 20 on 13. So to get the tan inverse function on your calculator, remember it's just shift tan. So doing that, once you've got those, input that information on your calculator, and what you should get is 56 degrees, 0.9761324. That's an answer as a decimal. We want it as a degree, so we use the degrees and minutes button to convert this answer into degrees and minutes and seconds. So pressing the degrees, minutes and seconds button, you get 56 degrees, 58 minutes, and 34.08 seconds. The question's asking us to the nearest degree, so we're going to round off. You can see that in our minutes section, it's 58 minutes. 58 minutes is greater than 30, so we need to round up. So our final answer is going to be 57 degrees. So now moving on to the next question. So scrolling down to the next question is find the angle theta to the nearest minute. So once again, before we begin doing any operation, we need to identify the sides and its relationship to the angle. So we have our angle here. So the first side I'm going to identify as the hypotenuse because it's the longest side and it's also the side opposite the right angle. So the hypotenuse is 1.9 meters. That 1.6 meter side is actually next to the angle, so it's our adjacent side. So referring back to SOHCAHTOA, we need to pick the most appropriate trig ratio for our question. So we need to pick a trig ratio that contains adjacent and hypotenuse. So we can see it's the CA. So CA stands for cos theta equals to adjacent on hypotenuse. So we substitute our values. So cos theta remains the same because that's what we're solving for. Adjacent becomes 1.6 and hypotenuse becomes 1.9. So we're solving for theta, so we need to do the opposite of cos. So the opposite operation of cos is cos inverse, so multiplying both sides by cos inverse gives you, so that's 1.6 over 1.9. So so that the cos and cos inverse cancels, and now theta is equal to cos inverse 1.6 over 1.9. So you can input that information in your calculator. So cos inverse 1.6 over 1.9 should give you 32.6368,975. So that's an answer as a decimal. So we want our answer in degrees and minutes. So once again, press the degrees and minutes button on your calculator and you should get 32 degrees, 38 minutes, 12.83 seconds. So question's asking us to find the size of the angle theta correct to the nearest minute. So I'm going to round it off to the nearest minute. So we can see here that our seconds is 12.83. 12.83 is less than 30, so we don't need to round up. We keep our answer as is. So our answer is going to be 32 degrees and 38 minutes. So that's our final answer. So now what I've actually got for you guys is I've got 2 questions that you can do on your own to see how you go. What you can do is do these 2 questions and I'll go over the answers in class. So good luck